Have you ever inspected whether we're truly alone in the universe? Of course, accepting that there's something more to our reality than whatever we see. Imagine a scenario in which the James Webb Telescope at long last shows that we live inside a black hole. Join us as we figure out more about this significant news that will make you question all that you thought you had some cognizance of regarding the universe. So, what exactly are black holes? They're like something out of an awful dream. Sure, you might have seen them in science fiction movies, but they're astonishingly, truly alarming. They're not only that. As shown by experts, black holes in space are considered colossal amounts of matter squeezed into an extraordinarily small region. Consider a star, ordinarily more enormous than the sun, all squeezed into a circle the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Investigators have been intrigued by black holes for a really long time. From the moment they thought about objects in space so gigantic and dense that they could trap light, the most notable thoughts about black holes were influenced by Einstein's theory of general relativity. Basically, when a tremendous star dies, it leaves behind a dense core. If this core's mass is several times that of the sun, gravity overpowers everything, prompting the formation of a black hole. It is no simple task to detect black holes since they emit no light. However, investigators have found ways to conclude their presence by observing their effects on nearby matter. For example, if a black hole passes through a mass of interstellar matter, it will pull that matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be annihilated, emitting X-rays as it does so. Black holes also greatly affect their surroundings. They can consume nearby stars, produce strong gravitational effects, and even influence the formation of new stars in certain areas while slowing it down in others. But where do black holes come from? Imagine stars, once massive, meeting their extreme destruction in a staggering event called a supernova. From the remains of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached their cosmic retirement party in a supernova explosion. Smaller stars, when they die, turn into something referred to as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these collapses occur, something odd happens near their surfaces. Time itself starts to behave strangely. From the perspective of someone far away, time seems to slow down near the event horizon, the point of no return for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to our own. Occasionally, when two smaller black holes collide, they merge to form a much larger and more frightening black hole. And if a black hole connects with a neutron star, they create a massive nightmare that defies comprehension. Scientists have been wrestling with the size of these enormous phenomena for decades. Black holes come in two sizes, large and small. However, small is relative when it comes to black holes. Stellar black holes, the remnants of massive stars, can be as large as 10 to 20 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone. That's a cosmic number of black holes that could swallow anything in their path. But wait, there's something even more massive. Supermassive black holes exist at the centers of giant galaxies, including our own Milky Way. These are millions, if not billions, of times more massive than the Sun. They resemble a massive dead void pulling everything toward them. Renowned physicist Stephen Hawking discussed black holes throughout his life. His lectures were always captivating, but some of his theories couldn't be confirmed due to a lack of advanced equipment. However, there's hope on the horizon. A single scientific instrument is making a tremendous difference, and we're not ready for it. It's called the James Webb Space Telescope, JWST, and it's here to delve into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel and a testament to the power of human ambition. Sure, we've launched other space telescopes before, and they've done their jobs well. But this one is truly extraordinary. The JWST makes the Hubble telescope, which has served us reliably for decades, seem like a simple speck in the universe. This price tag? A staggering $10 billion. Yes, you heard that right. This grand cosmic endeavor was a collaborative effort by NASA, the European Space Agency, and the Canadian Space Agency, with contributions from over 300 universities. Yet, such an ambitious mission comes with its risks. The JWST is venturing into uncharted territory, pushing the boundaries of what we know. Since its launch, the telescope has traveled over 1 million miles to its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its massive, 5-layer sun shield and giant primary mirror, both of which had to be folded to fit into the launch vehicle. Now, after NASA has aligned and calibrated it, the telescope is nearly ready for full operation. One of the most exciting moments was when NASA announced that the telescope had captured its first images of starlight. The initial image was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots from the star's light. NASA later released another stunning image of HD 8446, where 18 unfocused duplicates of the star were combined into a deliberate hexagonal arrangement. Once the telescope aligns its individual mirror segments, it will produce one clear, unified view. Thanks to its cutting-edge technology, the JWST will help scientists study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This era refers to when neutral hydrogen was reionized, given an electric charge again, by radiation from these early stars. Looking back billions of years is only possible with a powerful telescope like the JWST. The telescope will also assist in detecting exoplanets, which are difficult to observe due to their interactions with their host stars. Its powerful sensors will analyze these planets in more detail, sometimes even imaging their atmospheres. Understanding the atmospheres and conditions of these planets could help scientists predict whether they might be habitable. Beyond exoplanets, researchers are studying galaxies to understand how matter is organized on a large scale. This helps us grasp how the universe evolved and how the spiral and elliptical galaxies we see today developed over billions of years. The debate around the information paradox spurred decades of research and theoretical advancements. Scientists sought to reconcile quantum mechanics with general relativity, aiming to understand how information could be preserved when objects fall into a black hole. Some theories propose that information might be encoded in the radiation emitted by black holes, while others suggested it might remain on the event horizon itself in a form of holographic imprint, a concept stemming from the holographic principle. The holographic principle suggests that the entirety of the universe's information might be stored on a two-dimensional surface, much like a hologram that gives the illusion of 3 dimensions. This idea gained traction as physicists realized it could help resolve the information paradox. If the event horizon of a black hole acts as a holographic surface, the information of everything that falls into it could, theoretically, be preserved. In recent years, breakthroughs in computational astrophysics and quantum gravity have provided intriguing glimpses into the potential nature of black hole interiors. Some theories propose that the interiors of black holes are not simply featureless singularities but could be complex regions where space and time behave in ways unimaginable outside the black hole. One speculative idea involves wormholes, or Einstein-Rosen bridges, connecting distant regions of spacetime. Could black holes act as cosmic portals, linking different parts of our universe, or even different universes? While these concepts remain largely theoretical, they have sparked a new wave of interest in understanding black hole interiors. The James Webb Space Telescope has the capability to revolutionize our understanding of black holes and their surroundings. By observing distant galaxies, quasars, and active galactic nuclei, the telescope can provide unprecedented data on the behavior of matter and energy near supermassive black holes. The telescope's sensitivity to infrared light allows it to peer through dense clouds of dust and gas, uncovering regions previously hidden to telescopes like Hubble. This has already led to discoveries of complex chemical signatures and structures around black holes, hinting at the processes that fuel their immense gravitational pull. The idea that our universe might itself be inside a black hole is a provocative and mind-bending hypothesis. Some physicists suggest that the characteristics of our universe, including its apparent boundaries and the way time and space behave, resemble the theoretical properties of a black hole. Just as a black hole has an event horizon that limits what can escape from it, our universe seems to have a boundary beyond which we cannot observe, due to the speed of light and the expansion of space. This analogy has led some to theorize that our universe could be the result of a black hole in a parent universe. If true, this would imply that black holes might not only destroy information and matter but could also give birth to new universes with their own unique laws of physics. The implications of this idea are profound, challenging our understanding of reality and our place within it. Exploring these possibilities requires a synthesis of quantum mechanics, general relativity, and new theoretical frameworks that have yet to be fully developed or tested. The search for answers to these mysteries continues to drive advancements in technology and our understanding of the cosmos. The James Webb Space Telescope, along with other next-generation observatories, will play a crucial role in uncovering the secrets of black holes and the universe as a whole. Whether we are truly inside a black hole or not, these investigations push the boundaries of human knowledge, challenging us to rethink everything we know about existence as we continue to explore the vast unknowns of our universe. The James Webb Space Telescope stands as a beacon of scientific advancement. Its ability to capture data from regions of space that were previously out of reach will allow researchers to probe the very nature of black holes and their surrounding environments. As the telescope looks deeper into the cosmos, it may unlock answers to fundamental questions that have long puzzled humanity, such as the true nature of dark matter and dark energy, the formation of galaxies, and even the origins of life itself. One of the most exciting prospects of JWST's mission is its potential to observe the earliest galaxies formed after the Big Bang. By studying these distant objects, scientists hope to learn more about the conditions of the early universe, including how matter coalesced into the stars and galaxies that make up the cosmos we see today. These observations could provide a glimpse into the birth of supermassive black holes and how they evolved in the centers of galaxies. Additionally, the JWST's ability to study exoplanets in greater detail offers a tantalizing possibility: the search for signs of life beyond our solar system. The telescope's advanced instruments will allow scientists to examine the atmospheres of distant planets, looking for chemical signatures that might indicate the presence of life-supporting conditions. This has the potential to transform our understanding of life's distribution across the universe. Could we find another Earth-like planet? Or perhaps even evidence of alien life? Yet, despite all the advances in our understanding of black holes and the broader cosmos, there is still much that remains elusive. For instance, while scientists have made tremendous strides in understanding the behavior of black holes, the ultimate fate of anything that crosses the event horizon is still a subject of deep speculation. The singularity at the center of a black hole, where the laws of physics as we know them break down, remains one of the greatest mysteries in modern physics. Furthermore, there are still unanswered questions about the true nature of black holes themselves. While general relativity provides a solid theoretical framework for understanding their structure and behavior, quantum mechanics suggests that there might be deeper, more fundamental aspects to black holes that we have yet to uncover. For example, what happens to the information that falls into a black hole? Does it truly vanish forever? Or is it preserved in some form that we have yet to discover? These questions continue to fuel debates and inspire new theories in the realm of theoretical physics. As we look to the future, the role of the James Webb Space Telescope and other cutting-edge observatories will be critical in helping us answer these profound questions. The next decade promises to be an exciting time for astrophysics, with the potential to redefine our understanding of the universe. Whether it's uncovering the secrets of black holes, tracing the origins of galaxies, or searching for signs of life on distant worlds, the journey of discovery is just beginning. One thing is certain: the more we learn, the more we realize how much we don't yet know. The universe, with all its vastness and complexity, continues to challenge our understanding. And as we peer deeper into the cosmos, we may one day come face to face with the ultimate question of whether we are truly alone in the universe or if we are part of something far greater and more mysterious than we can imagine.